Alright, here we go. Section 3, or Chapter 3, Section 2. The first section we did was learning how to solve a system by graphing. Now the second section is all about solving a system algebraically. So no need to graph, which most people like this stuff a lot more than graphs. So and I think it's going to go quicker for us. So let's begin. You guys probably already know these methods, but it's a good refresher. So the first method is the substitution method. So if I give you a system, remember a system consists of at least two equations. And if I said, how do we solve, that means we're finding a coordinate, or maybe more, that makes both of these true at the same time. So how do you do that using the substitution method? Well, think about substitution. If I said to you right now, x equals 2, you would say, oh, x is 2, let me put that in here, and say, okay, x is 2, so then you'd kind of solve for y or something like that, right? So in these cases, when you use substitution method, we want to get a variable by itself. Now look at all these: 2x, 5y, x, 3y. Which one of these variables would be easiest to get by itself? This guy right here. If we just minus 3y, we would get x by itself. So minus 3y minus 3y. You could do this for any one of these. Get x or get y by itself. Doesn't matter. But this would be simple to do, to get x by itself here. So this becomes x, this is gone, equals 3 minus 3y. Right? Everybody with me? So this was equation 2. Now it looks like this. So this is basically new equation number 2, right? What you're going to do is substitute into equation number 1. X is not 2. Okay, that's easy. Oh, x is 2, plugging in. X is really 3 minus 3y. You see that? It's like a complicated expression. X is, this means is, x is 3 minus 3y. So we're going to put this into this first one up here. So 2x plus 5y equals negative 5. So since x is 3 minus 3y, I'm going to take out x right here. I'm going to just pull it out. I'm going to replace it. I'm going to substitute. Whatever x is. X isn't 2. X is 3 minus 3y. Okay? So 2 times x plus 5y equals negative 5. Now, what's nice about this is it's all dealing with y's out there. There's no x's. So this is going to be easy. 2 times 3, there's 6, minus 2 times 3y, 6y, plus 5y equals negative 5. Just do some normal math, okay, if I could say that, algebra. Minus 6y plus 5y is a negative 1y, or negative y. Okay, so I got 6 right here, minus 1y, or just y, equals negative 5. Get y by itself, so minus 6, minus 6. Negative y is equal to, this side becomes negative 11, which means divide by negative 1, negative 1, y equals positive 11. So far we got y equals positive 11. Now, when we solve a system, we're supposed to get a coordinate. You got the y value. So far, I'm going to scratch this out, and so far, 11 is my y value. How are you going to get x? Plug this in to one of these. What's the easiest one of these to do? It's actually this one right here. X equals this. So plug 11 in for y right here. So we got x equals 3 minus 3y. We got y is 11. So I'm going to substitute that. We got 3. We got this. Okay. So x is equal to, this becomes 3 minus, this is 33. So x equals 3 minus 33, which is negative 30. So negative 30 is my, comma 11 is my answer, my solution to the whole system. Now what if you messed up somewhere, which it happens, then this whole thing is shot. So make sure you got this, all your work right. How do you know if it's right? Plugging in both of these formulas. and it should work for both of them at the same time. Plug in negative 30, plug in 11, and you should get 3. That's true. I did that in my head. Negative 30 here, that's negative 60, plus 11 times 5, which is 55. So negative 60 plus 55 is negative 5. That's true. They both check, so therefore this is definitely the solution to the system. That's how you use substitution. Number one, you get one of the variables by itself. That was the easiest. And then you plug it in and you find your answer. Negative 30, 11.